You really need security analytics in addition to a lot of the traditional techniques we've been using. And so I'll be talking about the new job role that's becoming more and more popular, as well as talking about what a SIM does, a Security Information and Event Manager. My name's Patrick Lane. I'm at CompTIA. CompTIA is the Computing Technology Industry Association. I've been here for about 2.5 years, but have been working with IT workforce standards for about 20 years. And so I'm now the product manager for Security Plus, Cybersecurity Analyst, Advanced Security Practitioner, and our Server Plus exam. We work primarily with Enterprise and the DoD. Security Plus, CASP, and CSA Plus has been preliminarily approved for the 8570 list, and so these are all used by the military for people that are working with any kind of sensitive information. I want to tell you a little about myself. I grew up on Ronald Reagan Ballistic Missile Defense Test Site on Kwajalein in the Marshall Islands. And it's been in the news a lot lately. That picture down in the lower right-hand corner is actually an MX missile coming in. I lived out there in the 80s and 90s. And it's essentially where the U.S. tests our ballistic missiles to make sure they're accurate. Kwajalein Lagoon is the largest lagoon in the world, 90 miles long and 30 miles wide. It's like a pool for the missiles to land in, and in the early stages we could do triangulation before GPS to determine exactly where they landed, and the lagoon floor is only 180 feet deep, so you can easily retrieve the dummy warheads as they come in. Kwajalein is also one of the GPS sites, one of 7 running that. Also does deep space tracking, works a lot with the International Space Station, as well as NASA. There's a lot of NASA work being done out there. And I wanted to show you how remote it is. It's halfway between Hawaii and Australia. You can see Kwajalein there. And the island is, as I said, 3 miles long, a half mile wide, but it's located absolutely in the middle of nowhere. And the reason is because this is where Bikini Atoll is. Kwajalein was the headquarters for all of the logistics for all the Bikini and Eniwetok nuclear explosions when we were doing them above atmosphere into the early 60s. Luckily, Bikini was downwind of Kwajalein, so I don't glow at night. Okay. Here's the agenda. We're going to talk about why are security analyst skills important for intrusion detection. We're going to talk about security analysts. How do they, what tools do they use? How is a SIM configured? How is threat intelligence integrated? Then I'll run over a few real-world examples. Hopefully we'll have time. I'll go through that as fast as I can. So why have security analyst skills become so important? And they become important mainly for intrusion detection. And as I said, seminal event, Target Hack of 2014, was a real wake-up call to the IT industry. And it brought widespread attention to the Advanced Persistent Threat, the APT. And one of the only ways that you can fight an APT is to monitor all of your network traffic and try to find anomalies in it. I'll show you many, many examples. But it showed that a lot of the traditional tools we've been using, because I'm a Microsoft Certified Systems Engineer from the 90s. I started out in IT, laying cable, making sure, using a lot of RJ45 cable. It's why wireless is so wonderful. But it showed that firewalls and antivirus do not alone protect networks, because those are essentially have static rules. You have to have a rule or a signature file that will have a known attack, identify it. But if it's an unknown attack, a zero-day attack, then it doesn't help you. And that's one of the problems that occurred. A lot of people say, in general, that 2014 was really the year that cybersecurity changed as far as the skills needed to protect networks. So in many ways, you have these pre-2014 skills and post-2014 skills. with security analytics being post-2014 skills. However, security analytics have been used for years. People have been using security information and event managers for years. And so it's just now being widespread as more and more companies are being impacted. But the advanced persistent threat, of course, they never stop. They're often highly coordinated or state-sponsored. And it's when a bad actor will lurk on your network. They will then migrate from system to system trying to find targets. And once they find a target, then they can exfiltrate the information. And so they're very hard to detect because they can't be detected in most cases by, as I said, the antivirus and firewalls. And so what we realize is we have to apply behavioral analytics to IT security, mainly internal networks, to improve IT security. So we have to focus on network behavior, typically in an interior network. We want to identify any anomalies that might indicate bad behavior. And so what we have found is the CompTIA, being that we're a Computing Technology Industry Association and we create IT workforce standards, we are responsible in many ways for trying to create certifications based around job roles. And so with security analysts becoming so important, we have to find out, well, what do they do? They do a number of things, including threat management, vulnerability management, cyber incident response, and they use a lot of tool sets. One of the things with security analysts, you have to be able to use specific tools. And we'll go over those in a moment. The security analyst job role, after the 2014 hacks, what happened is the jobs for security analysts nearly doubled in the following year in 2015. And in 2016, the Bureau of Labor Statistics set a new record. Security analyst was actually the fastest growing job percentage-wise in the history of the Bureau of Labor Statistics. And so that really shows the interesting time we're in. And so right now there's well over 250,000 security analyst job openings. And then this is just emphasizing that it's the number one job growth with 37% overall growth between 2012 and 2022. And it's the same if you look at the 2014 to 2024 numbers. So it's remaining as the top growing job by the Bureau of Labor Statistics. And then why would anyone want a certification around this? It would be because about 80% of all hiring managers look at certifications when they're hiring someone, because the certifications will immediately show them, oh, this person has a skill. And by the way, in case you're not familiar with certifications or IT certifications, it's basically built from a job task analysis where you bring in people that do that job role. You try to mirror everything they're doing on a day-to-day basis, and you create exam objectives from those. If you get enough people involved, enough industry, like a couple thousand, you come up with really solid exam objectives. From that, then, courseware developers develop courseware for it, and test prep, and instructors get trained. And then the objectives go to exam development, and an exam development department then creates an exam around those objectives. And they're two separate things. But together, it provides the training and then the assessment that would prove someone has a particular job role. And they have to go to a Pearson VUE testing center in order to take one of these exams. And so, just quick advertisement, the CompTIA Cybersecurity Analyst CSA Plus cert, we developed it specifically to address the need for IT security analysts. Today, up on the top floor, we're actually doing a CSA Plus mini boot camp where we're going through a lot of the skills I'm going to be showing you today. So what tools do they use? There's three main categories of tools. You've got your typical network protocol analyzer, such as Wireshark. You've also got network intrusion detection systems, very popular ones, Bro and Snort. And also you've got security information and event management software, a SIM. And I'm going to be showing you a SIM as well. These just happen to be open source examples of these types of software, but there's a whole lot of tools that can be used that are created by vendor-specific companies, such as Intel Enterprise Security Manager, the Dell RSA Security Analytics, RSA NetWitness Suite, Splunk, a little more complicated, but it's been around for a long time. Security engineers really like it. And then Alienvault, that's one I'm going to be showing you some examples from, simply because Alienvault offers an open source version. There's also HP Security has got ArcLight, got QRadar from IBM, and Logarithm. I'll show you an example from Logarithm as well. Here's an example of a SIM. One of the things that is great about them is they have dashboards. We were at the RSA convention just a few months ago, and security analyst, was all the rage in security analytics. And one of the things that I was told is that when you look at a dashboard like this, it may appear to overly simplify what a SIM is and how a SIM is connected. But on the back end, to get this information, there's a lot of network reconnaissance going on that you have to configure properly. But this right here is an excellent dashboard, and they're used to visualize the data and to find if there's an issue or not. So in this case, in the upper left-hand corner, we've got some promiscuous hosts that we've caught. And mind you, this is just an overview. We're going to go into more specifics. But if you look at the bottom of that, you got an IP address there that's like the dark red. I think it's the 178, 172. I can't quite see it. It's in red, and it's the... Okay, good. But what that does is it shows you the promiscuous hosts. In other words, the hosts that are communicating the most on your network. And then you've got on the bottom left, you've got the events, and it's color coded. So you look down at the event where all that additional traffic's going on that host, and you see that there's a failed password attempts. You go to the right on the bottom, and the alarm is there, and it actually identifies it as a brute force attack. And I'm going to show you how that works as far as, how did it know that? Because it uses threat intelligence and it uses an open threat exchange. So as soon as it was able to, capture that traffic and identify it, it realized, this is an already known security issue, and it's already been posted by other security analysts, for instance, at Open Threat Exchange, and that's how I got that information. But that is a really great way to look at information quickly. You can also see trends and bandwidth issues. Like for the middle on the left there, you can see we had a lot of traffic going on there, and then it suddenly died down. Maybe that's an indication of a DDoS attack, for example. And here's an example of IoT. I was just at IoT World in Silicon Valley just about 2 weeks ago, giving a presentation about SIMs and how they need to be used for the Internet of Things. And that's very important right now because with the Internet of Things, with the WannaCry virus, we've got, that was actually reverse engineering, but the Mirai botnet, which occurred last fall, what it was is it was able to compromise IoT devices and form a bot army of IoT devices, and then launch an attack on a DNS server. And so that shut the services down for dying, and a lot of companies lost business for several hours. So one of the most important things about a SIM, Security Information Event Manager, is that one of the greatest things it does over, say, an IDS, an intrusion detection system, is that it can reduce false positives greatly. And that's one of the reasons why people like to use them. A false positive would be an alert you get, but it's not true. And so I'll show you how you can weed through those. But one of the SIM that I'm going to talk about now is they all function the same, but this is the open source version. So just so you get an idea, of course, in this case, it's the Alienvault open source SIM. We call it OSIM. It's free, as is all open source software, but your time is not free, of course. So you have to expect to be spending a lot of time with one. If you buy a commercial version, far easier to use, a lot of pre-configuration, and but they're very expensive. I mean, you're looking at a minimum of probably $32,000, and that's pretty good price if you're an enterprise corporation. I just want to tell you the parts of it and what they do. Because basically, what they do, there's several components. One is you have to have external data sources. And so these are all the devices that you need to collect information from. And that could be any device or any server. And so it could be your directory server. It could be various hosts on the network. Anything you want to get device information from, or a router, and it should be every device on your network. anything that's going to generate events, a log file that you can collect. And then you also have to have sensors, and these are basically collect information and normalize and format everything that is coming on, and you'd have to have one sensor in every network segment. Because in order to collect the information from all the segments, you have to have the sensor to collect the information, which then brings it to the server, which is next. The server is where all the computation goes in. It's going to conduct risk assessment. It's going to do the correlation directives, and that's what actually determines and weeds out the false positives, and I'll show you that. But also you have to store everything in a SQL database, and so storage is a very big deal. And if you buy the commercial version, for instance, of OSIM, it has Logger that comes with it, and it's just a huge database that it's a huge storage repository where all of your information would go and your logs, and you probably have to hold on to it for a certain number of years as well, depending on the regulations you're under. And then also a web interface. You have to have a really easy-to-use web interface, especially to create reports and such. And you'll see that the web interfaces are very simple, as you've already seen one example. But then you can drill down in layers as well. So basically what's happening, far left side, you have to collect input from everything. And this is input from all of your different devices. And so this is going to include everything, which I mentioned before. And so you have to make sure that you're getting information from all of your systems. And then it's analyzed at the server. And so this is where a lot of the processes that I was talking about, it's going to do blacklisting, it's going to do whitelisting, it's going to do the correlation that I talked about. It's also going to process the information, and it's going to use some basic analytics, or it can do contextual searches. It visualizes things for you so you can actually make decent decisions on the information you find. But what does it ultimately do? It gives you output to review. You have to look through the output and then analyze what is going on, if you think it's something you want to create a ticket for or not, to pass on to your team. And so you have to figure out, what are you going to do? It's called actionable intelligence. You have the information. What are you going to do? How high is the risk? And so at that point, you might also have to decide, okay, I'm going to have a ticket. We are going to have to do some forensics analysis on this. So as far as the installation of OSIM goes, most of them are going to be running on Linux or some type of it. We've got, in this case with OSIM, it runs on Linux Debian, and it comes with the OSIM and OSIM agent software. So it's just one ISO file, and you can actually load it in a virtual machine, and then you can play around and experiment with this, and it's actually quite fun. However, you have to have information that comes into it, because a SIM without information is not very good. But what you can do is you can do a VM and then just hook it up to a router, for example. Even if it's just at your home network, you can hook it up to a router and you'll get a lot of information, at least to begin going through. You can also, of course, spin it up on Azure or AWS. And so as far as the agents and the plugins go, every system would need an agent and a plugin. And so, as I said, a SIM is not good without information. So the best way to utilize a SIM would be in a banking scenario where you have a great deal of information coming in and you have a lot to look at. And so that's why I've got a lot of scenarios to show you that are of like a banking system and some other examples. And so the main goal of it, right, is you have to collect your logs from your host. So you've got to install an agent on each of your devices. This is what's going to forward the logs. So OSEC agent will do that on Linux, and then you can use Snare if you're on a Windows system. And to connect data sources to the OSIM server, you have to install a plugin. It's basically like an XML driver. Think simple network management protocol and management information bases. Very similar to that, just customized version of it. These plugins are built into everything because it uses that concept. Checkpoint, Cisco, almost every device is going to have a plugin for a SIM out of the box. Correlation. Now, this is how you reduce false positives, and this is one of the greatest things. You see, it separates the SIM from the IDSs, and this is a big deal because what it can do is calculate multiple input events and alarms into a more manageable number of events to address. And so it uses cross-correlation. So the example I'll give is if you have an attack and you've identified the destination IP address on your network, what you do is you actually look at the metadata that you might have assigned to that would show, is this a reliable server? Does this have, valuable information on it, assets on it? What is the priority of that? And so, based on the information that you have identified with that server, and, maybe it's a Bastion host, you're very confident with it. By checking the destination IP address, it could say, oh, well, in this attack with that particular server that we have hardened, it's not going to be a risk. And so we can basically, count that out. And so just by doing that one check of the destination IP address, seeing if it's, if it's reliable or not based on the data that you've input on that, you can reduce your false positives by 50% in that case alone. And now if you're a security analyst going through 95,000 alerts in a day, that's really helpful. Take it down to only about 45,000. And so it's the more you do that, the better the information that you're going to get, and hopefully you can remove a lot of alarms. That's the whole idea. And so correlation directive is basically rules that you can write. There are thousands of these pre-configured ones. That's the thing with even with Alienvault SIM, a lot of this is out of the box, and there's specific rules that you can choose to implement that are already written for you. And so, with a SIM, you're not creating things from scratch. There's templates and a lot of help that comes along with it, and the industry is geared for this. One of the great things is because a SIM is capable of identifying zero-day attacks, since it uses rules based on behavior. And so essentially you can write any rule at all to find any irregular information. But what you have to do, though, is you have to set a baseline first with your normal traffic patterns. And so that could be a challenge. But if you could get the normalized traffic, then you can find out, okay, this is normal traffic, what would indicate abnormal traffic? And those are the rules that you have to identify, and I'll show you some examples. So OSIM data management, what does it consist of? We mentioned before, raw logs from all the devices. From that, events are created. From the events, certain alarms would come out of those events. And if the alarm is something that you're going to follow up on, you create a ticket for it and send it to the help desk, for example, if you're working in a SOC center, for example. And so you can see your raw logs are sent to the OSIM server. They're normalized, formatted. They become events. But when does an event become an alarm? It becomes an alarm when the risk value of the event is greater than 1 on a scale of 10. And so this is just an interesting concept, just because I was talking about the metadata. What does the destination server, what kind of things are you looking for on the destination server to see if it's going to be vulnerable or not? Well, you take the asset value of it, you multiply it by the priority, and then you multiply that by the reliability of it, divide it by 25, and you get the risk of the event. If it's a 9 or a 10, it's usually considered to be a live attack that's currently going on. You can be, relatively sure. So if you have an asset value of 5, let's say it's a very important server with maybe a personal personally identifiable information on it with your customers. The priority of it, if that is a 5 as well, say it's a extremely important service for your customers, and the reliability. That is actually reversed. I know it's confusing. It's supposed to be reversed in this example, but if it's a 10, that means it's very unreliable. So in this case, let's say that we've got it's an old legacy system that we can't patch. It's a classic situation. And so it's very important to us, but, for whatever reason, maybe there's some upgrade issue we're having with JBoss and we can't do it to get the latest patches on. What do we do? And so in that case, maybe the access value 5, the priority is 5, the reliability, that is reversed, so that would be 10, which means it's very unreliable. So that would be 250 divided by 25, you'd have a 10. And so in this case, you'd say, okay, this is going to be brought to me as an alert. But that's basically how one of the calculations that's done in the back end. And that information there, you have to identify yourself for each resource. At that point, then, a ticket could be created after you've reviewed the alarms and assigned to the appropriate personnel. Of course, if you're in a medium or a small company, you're probably going to be doing it yourself. But if you're at a larger company, an enterprise company with perhaps over 1,000 employees, you might have a security operations center that might have a group of security analysts, a group of intrusion response specialists and such that you'd be working with. But if it's a small company, you might be doing it all by yourself. So here's reporting. It's just very easy to do reports. You just go through and configure anything you need that you want to output. But it's a very easy interface to select what information you want. Dates, incidents, and you could essentially print something out as needed, especially for forensics. And so the other important part is Open Threat Exchange. Open Threat Exchange is by Alienvault, but it's an actual environment where any security analyst can go and post issues they've found, and then you can integrate that information into your SIM in order to find zero-day attacks. And so the way threat assurance works, or threat intelligence works, in this case, you usually have a group that's in charge of the forum. In this case, Alienvault, and so they're constantly posting legitimate issues they see. But what you can do is you can actually create any kind of forum with trusted partners that just you have, and you can use OTX. Like, for instance, financial institutions, they band together, and they might have 5 or 6 of the financial institutions working together, sharing threat information, so that one bank can help protect the other bank, since they're all going to be vulnerable in most cases to the same malware. And so it's important to be able to seek that information. And so Open Threat Exchange is ideal. There are a lot of others. I'm just talking about OTX because it's the one that I've worked with. But I know that there's about 10 million viruses identified, or incidents that are identified every day. 10 million. And there's about 53,000 people that are subscribed to it. You don't have to listen to anybody. You can just basically take the different pulses that you want, which are similar to a Tor feed. Here is threat intelligence being used. As I'd mentioned before, we had wondered, how the SIM knew what that attack was with the brute force attack. Well, here it's identified a whole lot more. It's actually identified a Chinese DDoS attack. It's got Operation Armageddon. Oh yeah. It's also got the Forbes.com waterhole attack. See, all these are going on in this network at the moment, and so that is not good. And so you can also tell exactly where the information came from. If you look down in the bottom right-hand corner, what you're going to find is a system that's got all of the events by the sensor and where the data is coming from. And so you can actually see what device that a lot of this traffic is coming from visually. Also, it's used to find out where a lot of your traffic is coming from. In this case, what you've got is we've captured some network traffic, and we're actually going and identifying where all of this traffic is coming from and what type of traffic it is. In this case, most interesting, from this screen capture, you can see there's the majority of traffic or port scans coming from China. And number 2 is coming from the United States. So, and then where's Russia? There it is. 1, 2, 3, 4, 5, 5th. So I just think that's fascinating. It just shows what's going on at any given moment on your network. Here's some examples. Here's a Logarithm financial server hack discovered. Logarithm is a great SIM. So in Logarithm, the alerts would all just show up here on a dashboard, or the alarms rather. Now these are the ones that security events that were upgraded to an alarm. They made it past the correlation test. And so now you have to look and say, how can I prioritize this? Now I gave you a 1 to 10 rating. Logarithm uses a 1 to 100 rating. It's whatever is configured. So in this case, we've got a 100. So we know that there's probably an actual attack going on here. In this case, it says compromised system, and there's anomalies detected. So if you click on that, it all goes in layers. You go down one layer, and then you see this. And I'm just going to explain this to you. But essentially what we have found out here is in the left-hand side, in the middle, we realize, there's a temporary user that's been used for this attack. We also go down the bottom left and we see, okay, we've got our financial server has been accessed. And then on the right-hand side in the red box, we see Dropbox has been accessed by that temporary user. And so from this, you can see some highly suspicious activity. And this is activity that wouldn't have been found by a firewall or any kind of antivirus software, because what has happened here is that a temporary account has been created by someone who had authorization to do that, an administrator, perhaps a stolen username and password, created a temporary account, then exfiltrated information from the financial server and then uploaded it to Dropbox. And so this would be highly suspicious, and we'd want to follow up on it. And so if this were the case, what would we do? I'm going to go over a couple of solutions here at the end. Okay. Now I'm going to show you an example from Zingbox. And this is fairly new. Now we've got SIMs that are specializing. SIMs have really, traditionally just been used for PCs, servers, routers, the usual. But now with the advent of IoT, a SIM will still work, but now we have specialized ones for SIM rollouts. And so when I was at IoT World, one of the big messages being sent out was you have to do, managed IoT rollouts. And so, Zingbox was well received there because it's a little easier to use. But essentially here, this is network reconnaissance. I'm just showing you an example from Zingbox. What this is, it has been, they brought in information of medical devices. So this is at a hospital. It's all IoT devices. We have, an imager. We got a point-of-care analyzer, an ultrasound machine. And so, from this, we can see all the devices that are hooked up. And then, if there's intrusion detection, you'd get an alarm, very similar to what we saw before. But in this case, instead of giving you, 0 to 100, it actually just has a low, medium, high risk level. And so at that point, then you could decide, okay, we've detected something. How real is this? And then you can monitor and defend. So in this case, we've got a camera that we're watching, and we're saying, okay, who's accessing that camera? Well, if you look at the bottom here, we have an international connection from an FTP server, highly suspicious. And in that case, we would want to, look at that IP address, perhaps block it. I'm going to show you an example from Splunk. And this is a database hack that's been discovered. Now, in Splunk, it's very complicated. I know a lot of, some of the guys I've been working with that have been working like a Big Blue, in the 80s, 90s and such. They're all familiar in 2000. They're all familiar with Splunk. But it's not easy to use, and the interfaces aren't as easy. But if you're a real IT geek, you'll love Splunk, and I say that lovingly. Okay, so in here you can see with this particular interface, it's not pretty. The way this works, though, is it goes from left to right is the timeline, and the first box you see there is a series of attacks that have gone on, brute force attacks on the cloud web servers. In this case, those cloud web servers, you're very confident with them. Perhaps they're being run by a third party, and you're okay. you're not worried about those. However, if you go to the right and you look at the blue, that's a critical database server you have, and it's database 01. And so in this case, you realize there's been some access attempts on it. And then 8 minutes later, you've got another attack on those original systems. And so this would be suspicious, because you could say, well, if I've got that attack, maybe I have some more fun to look forward to with the critical database server. So in this case, we can look further into it. And when we do, another not too lovely scene, but at least we can see the forensics of what's going on here, because what this shows, going from bottom to top, is that essentially someone tried to log into the database server using a default DB admin account. They failed, and so then they tried a default Oracle admin account to get into it, and they actually succeeded. So as you go up, you'll see, okay, they succeeded with those 2 Oracle ones. But then what the administrator did with the Oracle, probably used a default username and password, actually granted privileges to a user called HAX0R. And then you can see Haxor then went and grabbed the customer service file and has exfiltrated the customer service info file. Now, if that was personally identifiable information, then you might be facing some steep fines depending on how you're regulated. And whether or not you have to disclose this, of course, would also depend on that. And so, not as pretty, but at least we've identified the issue. All right. Now I'm going to show you an example from Alienvault. This is a brute force attack discovered. Alienvault is the commercial, or that's the company that does OSIM, which is that open source SIM. But Alienvault also has USM, which is Unified Security Manager, or Unified Security Management. And they call the SIM that because they want to give it a newer, more gentle name, is all I can consider. Because they claim that if you configure the Alienvault USM, you can actually have information within 30 minutes once you've configured it. And that's pretty good, considering I talked to a guy from IBM who said it took them 12 to 18 months to set up a SIM back in the day. I just couldn't believe that. And so technology has progressed rapidly, and this is becoming a lot easier to do. All right, in this case, we've got a delivery and attack. We're going to focus on this, but you'll notice the different categories that are established. And in this, the way that this works is that if you've got a great deal of traffic, it actually just visualizes it by showing you larger images, or larger dots in this case. So we're going to focus particularly on the delivery and attack for this example. And we can see that there was definitely one big event that occurred. So in this case, the alarm details list is just down below. So once you find some activity, you can just scroll down. And then what you're going to find here is, voila, we have the delivery and attack. In this case, it's a brute force authentication attack. We see it's 7 events have occurred. Each one lasts about 4 seconds, and it's been going on for about 2 hours. So in this case, we're going to want to look into it and find out, okay, what else can we find about this? And then we look in, and oh, look, it's Operation Armageddon. It's the Russians. No. Yeah. Operation Armageddon, that was the cybersecurity campaign that Russia launched on Ukraine during the Crimea annexation and after that. So I just put that up there for a joke. That really wasn't Operation Armageddon. But what this is showing you is that when you do identify something, it talks to OTX and it pops up on the screen just like this. And so you'd quickly know exactly what you're dealing with. And that's just how the Alienvault one works. You've seen some other examples too. So I just want to summarize some of the incident response and post-incident response process. Because, what do you do after you find one of these issues? Well, there's some basic basic containment techniques that are used out there in the field. One is a segmentation, and I told you this about segmentation before, is that any network segment, for instance, if you have a SIM, has to have a sensor on it to collect information from all those different devices on that segment. But it's an excellent way to partition your network, essentially, so that if you have any kind of an incident in one segment, it'll be protected from the others, because a lot of times most issues that we have would remain on one segment depending on how advanced the attack is. But it can certainly help you a lot. Next is isolation, and so if you have a system that needs to stay running but it's been compromised, you're going to want to isolate it. You could even launch a quick VLAN, throw it on that, but get it off of the network if you can. Another is removal. If it's a device that perhaps you're going perhaps you're the Democratic National Committee and you're under attack, you just turn the servers off in some cases and just remove them altogether from the network. Another containment technique, though, is reverse engineering, and this is really exciting with the WannaCry virus or ransomware that just came out. They used reverse engineering to actually find out the problem. And so what was the guy? I forgot. It's a guy here in the U.S. up in Michigan who looked at the code of WannaCry and found a URL of gibberish, and it was a domain that was like XZ43819 or something, just very random. And he found out that basically it had a kill switch in it, and so whoever developed it had put in this kill switch so that every time the ransomware launched, it checked a URL, and if that URL was registered, then it would not run the attack, and if the URL wasn't registered, then it would run the attack. And so when he found this, he then activated the kill switch and, thwarted the attack because he registered for $10 that domain. And then when all of the WannaCry went out when it executed, it would go check and it would see, oh, that domain is registered, so I'm not going to launch. It's really amazing that they found that out, but you can see how simple in many cases it is to thwart some of these attacks. And so you can also use sinkholes, and in this case that is exactly what happened with the WannaCry. Basically the fellow redirected all the traffic going to the domain into a research server that they had so that they could then analyze all the traffic coming in. You can imagine you have quite a large pool of data for that. But the sinkhole apparently was already in place that they already had, so it was quite easy to direct all of the new potential ransomware attacks directly into the sinkhole, and they just went away, just like a sinkhole on the street, disappears. Also, eradication techniques include like a sanitation or a data wipe. Data wipes are being used a lot on remote systems nowadays, especially remote phones and such. You've probably all seen you have the ability to wipe your phone if you lose it. It's the same thing, just making sure there's no more data on that system. A lot of software can do this. It also would depend on what kind of regulations you're under. You can also just re-image the systems if you can, if you're allowed to. And then, of course, you can do secure disposal, where you actually, have them shredded. And that would be used in many, military environments. And so, what else can you do? You need to validate things. So this is the post-incident response. So you think you've fixed it. What do? You want to check, make sure you've got your patches in there. You want to check the permissions, that they're still accurate. You want to do scans. You want to make sure, run a vulnerability scanner. Make sure that you're not having the same issues coming back to you. But you also have to verify logging and communication to security monitoring system. Because if there's attacks going on and the information isn't coming to the SIM, you're not going to know about it. And so you really have to make sure that it works. It reminds me of a backup plan, because there's so many times in the past where a corporation thinks that their backup plan is working, and then a disaster occurs and it turns out the backup didn't work, or they couldn't retrieve it properly. And so it's the same thing with a SIM. You just have to constantly, check, make sure that your system is still logging properly and you are getting information from those devices. Some of the corrective actions, you should always create a lessons learned approach or a lessons learned report. Also, any changes that you're going to do to your processes, you have to make sure they're controlled and coordinated. So, if there's an issue, you fixed it, you then have to communicate that out to everyone. And then if you're going to implement changes, everyone has to be included on it. You can't just be a lone wolf and trying to fix it yourself. And then you'd update your incident response plan as needed and write up an incident summary report. And so, that's it in a nutshell. Are there any questions that anyone has? Yes. You want to...
Going back to your mathematical expression of risk analysis, the variable asset value, is that the dollar value of the computer or the router? How much does it cost? On a scale of 1 to 5, 5 meaning $8. Okay, so that's the cost of the part. Priority. What is priority?
Yeah. Let me answer these questions because I actually wrote down some of that stuff. He's just wondering with the risk calculation we did. He's wondering exactly what what each of those means, and so I'm. Right. No, this is a really good question. Let me just go back here. Okay, here's what I got. So an asset can be a host, host groups, network, and network groups. And so it's basically, the value and the information on it, how much it would be. A priority measures the event's, importance. So, and that's going to be, is this system you have, important? Is it being used a lot? Or is it something that's, rarely used? Maybe it's an, old, server it's legacy, nobody uses, it's got an old system on it. Reliability, that's the trustworthiness of the asset. And so trustworthiness would just depend on, is it a hardened, bastion host? Is it a legacy system? How reliable is it? Has it been patched? You can give it a score. Yes, that's a way of looking at it. Yeah. Okay. Yeah, as far as... Right. Oh, so this is all just, you can basically define anything the way you want it. This is just one particular way that it could be explained. But essentially, when you set up a SIM, you set up, exactly what those are going to be. That was just one example that I was trying to show you for a concept of how the calculations are actually, could be made by a system. But everything would be customizable. If you were doing it, you might not set it up with those exact names. All right. Yeah, using various elements that are based on that. Yeah, under some basic umbrellas, yes. Right. It's even the metadata that we talked about is you identify it, you define it, and you identify it. So it depends on your network and your customizable situation. All right. And how are we doing on time? I actually haven't even looked. 4 minutes? Okay, excellent. Any more questions? Oh, we do. Please, sir.
Good morning. My name's Jay Myrick. I had one question that you kind of touched upon and wanted to check to see. You had mentioned port scanning from a state actor. And would one be able to detect that based on net flow? So you see a state actor appears to be doing a port scan to multiple host machines, multiple IP addresses within a specific enclave. But it's it's small bite size, single packet, and you see the state actor utilizing various data services that have known vulnerabilities. And is that more of just a probing type of action?
Well, I had some information on NetFlow, actually, that I had gone through pretty quickly. Oh, yeah, here it is. So we're talking about some of the tools that we've got. These are some of the objectives. But essentially, yes, NetFlow is used all the time with SIMs. And so it's one of the, it's essentially the same, instance where you're collecting information from, routers and getting all the traffic coming into the interfaces, inbound, outbound. And so, from that information, could we determine such an issue?
That
Yes,
would be my question.
we could. It's one of the inputs that would come into the SIM.
Okay.
And it's used primarily exactly as you said.
Very good. Thank you.
All right. Some other things, point-in-time data analysis is what it's all about. So not only can you do NetFlow analysis, but, packet analysis, just from looking at the packet itself to the protocol going into perhaps DNS and looking at, packet headers and things, as well as wireless analysis. Yes.
Hi, my name is Jeff Siegel. I'm interested in IoT edge devices and kind of the gateways. And you talk to the network vendors, some of whom are here, large cellular vendors. So they have a panel and they're doing a certain amount of network analysis. Apparently, they have a separate internet routing for some of this IoT traffic. So just can you talk to what's the difference between what they're doing and how you're interfacing, what's coming in? What do you see in the future as IoT starts to explode into a much larger
Right. Well, one of the things we talked about was Zingbot, or Zingbox, which is a particular SIM made for IoT. And this was one of the ones I learned about when I was at IoT World to find out, and this is the example I showed with the IoT medical device intrusion. And essentially, there's very little difference as far as the way that it goes. And the concept is that, any device hooked up to the network has, X number of components that would be shared with other devices hooked up to the internet. And so the interface is very much the same. The process is very much the same. Probably the difference is going to be in the agents that you're using, because typical agents have been for servers and and PCs, for example, and now you've got these smaller devices. You might even have embedded devices, and how are you going to get information from those embedded devices? And that would all boil down to making sure that you've configured, in the case of it's the SNMP aspect of it. I was telling you about the XML drivers that you have to get. And I can tell you, I'm sure that the OSIM agent probably wouldn't work on an embedded device. I could guarantee it. And so you would have to have different agents out on your IoT devices. You would have to customize for them, which could be done. But essentially, it should run relatively the same. All right. Any other questions? Are we at our time? Okay. Hey, thanks everybody for showing up today. I hope you learned something, and have a great day. Thank you.